Chapter 9 is on chemical equations. Chapter 9, Section 1 introduces chemical reactions as substances reacting to be changed into something different. So you have to produce something new with a chemical reaction. Reactants are typically listed on the left side of the equation, and then the products are listed on the right side with an arrow or yields symbol in between. So the thing we need to make sure of is that when we're writing a balanced equation that we include the same type and number of atoms on both sides of the equation. They're just going to be rearranged in a different order. That will allow us to observe the law of conservation of mass, meaning that no elements are created or destroyed throughout this particular equation. Some evidence of a chemical change: heat, light, or sound being produced, a gas, so maybe you smell an odor or you see bubbling occur, a precipitate, which is abbreviated PPT, that's when a solid gets produced, so perhaps you start with two solutions and end up with a solid. That would be a precipitate, and a color change could also be evidence of a chemical change occurring. Now these are just pieces of evidence that suggest it could be a chemical reaction. It's not conclusive. The only way you know for sure is to actually test in the actual laboratory. Physical changes, if you recall from earlier in the year, are when you have a change but you end up with the same composition both before and after the reaction. So usually things like state changes, so like melting, for instance. In this picture here we've got an ice cube that's melting. It's still water, it's just going from the solid form to the liquid form. So it is changing, but we're not changing the actual chemical itself, so that's only a physical change. Now with chemical reactions, you're always going to have some sort of energy change. Energy can be either absorbed or released. If the energy is released, then it'll be an exothermic reaction. So energy could be written on the product side of the equation, and it'll either be written as a capital E. It could be completely written out as energy, or you might see a certain number value and then kilojoules or joules that would represent the amount of energy that reaction would be giving off. If energy is being absorbed in the reaction, then that would be an endothermic reaction, and in that case the energy would need to be written on the reactant side of the equation. And finally then, activation energy is just how much energy that it actually takes for a reaction to occur. So in order for this to happen, particles have to be able to have enough energy to get them moving and then also to collide with one another. If they never come in contact with each other, then they can't recombine to make something new. You probably talked in biology class about enzymes and how enzymes are catalysts that will help to speed up reactions. Well, they do that by lowering the activation energy. That's going to allow the reaction to happen more quickly. Reactions that have enough energy available to begin on their own are called spontaneous reactions, and those that need energy in order to start would be non-spontaneous. So you would have to give them some form of energy in order to actually happen. Perhaps hook them up to a battery or generate some sort of electricity, heat them up, something like that. You'd have to provide energy in order to make a non-spontaneous reaction occur.